In this video, we're going to learn about one- and two-step equations. And we'll start off with one-step equations. Here's an example. 3x equals 6. We can probably just solve this by looking at it and say that x equals 2, because 3 times 2 is 6. But the goal is to use math to solve it so that we practice for more complicated problems. So since the 3 is multiplied by the x right here, there's a little dot in there that you don't have to write, but it's there. You divide both sides by 3 to undo the multiplication of 3. And then these cancel out, leaving 1's behind, which don't end up mattering. So x equals 6 over 3, which is 2, just like we thought. Another example, x minus 4 equals 7. Again, we can probably look at this and say, well, x needs to be 11 because 11 minus 4 is 7. But the goal again, so we'll say x equals 11. The goal again is to use math to solve the problem. And we notice that the 4 here is subtracted. So we want to undo that so we can get this x by itself. And so what we do is we add 4 to both sides to get rid of the 4 that is subtracted, plus 4. So then x equals 7 plus 4, which is 11. Here's another example. X minus, or rather plus 6 equals negative 4. Well, this one isn't quite as easy to solve in our heads, so let's just go ahead and use math to solve it. We want to get rid of this plus 6 so that we get the x by itself, and the way we get rid of a plus 6 is we subtract 6. So we just go minus 6 on both sides, because remember, equations are like balance scales, and what you do to one side of a balance scale, you have to do to the other. If you take 6 pounds from one side of a balance scale, you take 6 pounds from the other. These will cancel, and you'll be left with x. And always line your equal signs up. That's a nice thing to do. Minus 4, minus 6. Well, that's negative 10. And one way to think about that is if you are standing in the desert and you're at elevation 0 and there's a flight of stairs that go infinitely up and infinitely down underground, you would go down 4 steps and then down 6 more steps, and that would be down a total of 10 steps, so negative 10. Here's another one. X over 5 equals 4. Well, again, we might not be able to look at that and solve that too quickly, so let's just go ahead and use math again. We need to get rid of this divided by 5, because then we get x by itself. So what we do is we just multiply both sides of the equation by 5, because multiplication undoes addition, but we have to multiply the right-hand side by 5 as well, so we end up with x equals 20. We can actually check our work too. We can say 20, x is 20. Does 20 divided by 5, does that equal 4? Well, yes it does. Now let's try a couple of two-step equations. 3x minus 5 equals 10. So the trick here is to again get x by itself. So to get x by itself, we have to get rid of this, but we also have to get rid of this. Which one goes first? Well, I have a nice method to figure that out. Most of you have probably heard of PEMDAS. P-E-M-D-A-S. It stands for parentheses, exponents, multiplication and division in the order in which they appear, addition and subtraction in the order in which they appear. So when we do math in this direction. We do parentheses first, then we do exponents, then multiplication and division, and then addition and subtraction. But when you are solving equations, you do it backwards. You undo subtraction and addition, then you undo division and multiplication, then you undo exponents, and then you undo parentheses. So that's the trick to remembering what to do first. So if we follow that, we undo any subtraction first. Well, we have some subtraction, negative 5. So we undo that by adding 5 to both sides. These cancel out. 3x equals 15. Then we undo addition, but we don't have any addition to undo. So we move on to, oh, I'm sorry, we have no addition to undo. Then we move on to division. We have no division to undo. So we move on to multiplication. We certainly have some multiplication to undo right here. We have to undo that multiplication by dividing both sides by 3. Divide by 3. These cancel out, leaving 1s behind. So x equals 5. So there is a two-step equation. Here is another two-step equation. We need to get x by itself once again. We have a 5 here. We have a 5 here that is added to both sides. There's an invisible plus sign in front of it, minus 6x. So there's a times here. We need to get rid of this negative 6 that is multiplied by the x. And again, we use the opposite of PEMDAS. PEMDAS. So we go backwards. So we undo any subtraction or addition. And then we undo any division, multiplication, and then exponents, and then we undo parentheses last. You might look here and think, well, I have some subtraction here that I should undo first. But actually, this is a negative 6 that is multiplied by x. So this is actually a multiplication. So we're going to save that for later. We're going to undo this addition of 5 by subtracting 5 from both sides. These cancel out. Negative 6x equals 18. And then we have to undo the negative 6 times x by dividing by negative 6. These cancel out, leaving you with 1s. Divide negative 6. So x is equal to 18 divided by negative 6. And what I like to do is evaluate the signs first. There is an unwritten positive sign here, right in front of the 18. And positive divided by negative is negative, just like positive times negative is also negative. So we evaluate the signs first, and we know that our answer is going to be negative. Now we can ignore the signs. We just ignore them. And what is 18 divided by 6? Well, that's 3. So then the answer is negative 3. Here's another equation. We need to get the x by itself. So we want to get rid of the division of 7, and we want to get rid of the minus 3. You might think that if we do use PEMDAS backwards, I'll write it again. You might think that you would get rid of the negative sign first, but actually, this is locked inside invisible parentheses in the numerator of the fraction. So we actually have to save that to last. So what we need to do is we need to get rid of the division of 7 by multiplying both sides by 7. Multiply by 7. These cancel out. And so you're left with x minus 3 equals 12 times 7, which is 84. And if you don't know that immediately, you need to download our times tables app, which is just called Fusion Math Fast Facts. And you can download it from Apple's App Store. It's for iOS apps, iPhones, and iPads. And it's free, and there's no ads. So please download it and use it. Get better at your times tables. Now the x minus 3 is out of the numerator, so we can just add 3 to both sides. 3's cancel out, and x equals 87. Here is another two-step equation, and this is kind of an interesting one because there are actually a couple ways to solve it. Here's the first way, which I find to be the simplest. If we rewrite it, 7 2x minus 6 equals 56. The simplest way to solve it is to recognize that the 7 is multiplied here. Therefore, I'm going to divide the left side by 7, divide the right side by 7. These 7's cancel out, leaving 1s behind, which don't end up making a difference. Now we have 2x minus 6 equals 8. And Now I would add 6 to both sides, and I apologize because this is kind of a 3-step equation. And I'm going to add a 6 to both sides, plus 6. These cancel out. 2x equals 14, and x equals 7. Here's the other way to solve this problem, which is actually slightly longer, but it still works. 7, 2x minus 6 equals 56. You could distribute the 7 to the 2x and the 7 to the negative 6, giving you 14x minus 42 equals 56. And then you would have to add 42 to both sides. And then these would cancel out, and you would have 56 plus 42 would be 98. So 14x would equal 98. And you might say, well, I don't know what 98 divided by 14 is. You would divide both sides by 14, divided by 14. And it's always nice to solve problems without calculators. We leave some ones behind here. How would we do 98 divided by 14? Well, here's an easy way. 98 is actually twice 49, so it's 2 times 49 over 2 times 7. These 2's cancel out. 7 divided by 7 is 1. 49 divided by 7 is 7. 7. So x equals 7, just like on the other side. But I think that the left-hand method is faster. Although the right-hand method still works. You can distribute first, but generally it's better to get rid of this first.